Hi guys, welcome back. Today let's try to solve this problem. It is daily question and it's 779 Kate symbol in grammar. What does it mean? Yeah, okay, let's go to the description. We build a table of n rows. Okay, they're going to be rows. Okay, they're going to be rows, and we start by writing 0 in the first row, and it's also mentioned that it is one indexed. Let's remember that. Okay, we start by writing 0 in the first row. Okay, it's going to be a 0. And now in every subsequent row, we look at the previous row and replace each column 0 with 0, 1. Okay. We have for the second row, we're going to look at the first row and we're going to replace 0 with 0, 1. And similarly for the next row, 0, 1. And now let's go to the third row and we will replace 0 with 0, 1 as mentioned. And it also mentioned that you have to replace 1 with 1 and 0, which means 1 and 0. And it just keep going on and on and on until the end. So they mentioned, so next row is going to be 0, 1, 1, 0, 1, 0, and 0, 1. Correct? So that's it. That's what the problem means. And they are just asking, you have to get the kth index from the nth row. So if n is equal to 3 here, you just have to get 1, 2, 3, the n is going to be 1. If n is equal to 7, it's going to be 0. And for this, I'll explain it in a notebook so you guys can understand it better using binary search. And I'll see you back.
Hi guys, welcome. Now I've taken an example where n is equal to 4 and k is equal to 7. So we have to find the 7th indexed element from in the nth row. The nth row is going to be this 0, 1, 1, 0, 1, 0, 0, 1, and this is going to be the 7th element, correct? And we are going to find it. We're going to find it 0 by using binary search. No, I know it could sound funny, but this actually works. I'll explain it to you. And before proceeding, I want to show you a pattern. So when we proceed to the next row, what we're doing is, if it is 0 to the left side, the element is going to remain the same. But to the right side, it's going to change. If it's 0, it's going to change to 1. If it is 1, it's going to change to 0. But in the left side, it's not going to change. For example, you take this value. In the left side, it's going to stay 1. And in the right side, it's going to change to 0. It's going to change to 0 if it is 1. And if it is 1, it's going to change to 0. So that is a pattern you have to remember. I'll explain it again. To the left, it's going to remain the same. To the right, it's going to change. If it is 0, it's going to change to 1. If it is 1, it's going to change to 0, and so on. So in the left, it basically doesn't change. You can see the pattern. It doesn't change. So that is the pattern we're going to use to solve this problem. And in binary search, as you know, we are going to use 2 pointers, and one pointer is going to be at the beginning, and the another pointer is going to be at the end. And how can we get the end here? So it's basically 2 power n minus 1. I've done it manually, and you can see there are 8 elements. And for n is equal to 3, there are 4 elements, which is 2 power 3 minus 1, right? Which is 4. So yeah. So now the left is here and right is here, and this is the fourth row, right? N is equal to 4 and fourth row. Now, where is the middle element? The middle element is here. It is right plus left by 2. Correct? When you do that, you're going to get the middle element here, which is going to be 4. And this is the fourth element. Now, as we do in all binary search, we're going to check if the target is to the right or left. K is to the right, correct? K is the right of middle element. So we're going to shift the left pointer to mid plus 1, which is here. Guys, when K is to the right of the middle element, you have to shift the left pointer here. When K is to the left of the middle element, you have to shift the right pointer to middle. That's how binary search works. And now when we do that, we get this. 1001 and K is here, and this is gonna be the middle again, left and right pointers. We're gonna do the search again, and K is gonna be the right again, and I forgot an important point. When in this case we have to change, if current is equal to 0, we're going to change it to 1, else we're going to change it to 0. That's the pattern, remember? So when K is to the right, we have to change. So when it is to the right, we have to change current is 0 1 1 0. Okay, now the current value is 1 because it was to the right. Now we are checking again, and the K is to the right again, and we're gonna change current to 0 again. I hope you guys understand me. I'll explain it again. If this is middle and K is here, it is to the right, so you have to change the current value to its inverse. If it is 0, you have to change it to 1. If it is 1, you have to change it to 0. If it is to the left, you don't have to care, because in the pattern, the left, the element doesn't change. Okay. And now, after this, the left is going to be here, guys. Yes, you guess it correct. So this is it. And left is here, right is here, and we're going to check K again. And we break out of the loop right now because we found this. And now we're just going to return current. It's going to be the value. I'll explain it in code, in the lead code, and this is basically the binary search intuition behind this, and I hope you understood this.
So guys, yeah, welcome back to the lead code, and let's solve this. So how can we proceed with this? So as I mentioned, we are going to return the current value which we change depending on whether the value is to the left or right of the middle element. So we're going to return current. We also initialize that as 0 first, because 0 is supposed to, let's not put it. Okay. Now the 2 pointers, left and right. In left is equal to obviously 1 because it's 1 in left, and right is equal to this one. I hope you guys understand how it's done. For the first row, it's 1. For the second row, its number of elements is 2 and 4 and 8. As you can see, the pattern is 2 power n minus 1. Correct? It's 4, so 2 power 4 minus 1 is 3, and total 8 elements. So the right pointer is going to be at math dot power 2 comma n minus 1. Okay, what's next? So we have the pointers right now, and now I'm going to initialize a variable int I is equal to 0. You guys will understand why I do this. It's basically we are going to do the binary search as many times as the rows, so that we'll be able to reach the kth element. You'll understand it when I code. So I'm just gonna use a while loop, and here let's mention I is less than n. It's gonna increment. Okay, it's gonna keep doing the binary search until it reaches the nth row. I mean, you have to do it n times in order to reach the kth element. That's how it works in the binary search. And so we're gonna do binary search as long as it's inside the loop. And for binary search, we're gonna start by saying int mid is equal to left, left plus right divided by 2. Correct? Yes. And now, very easy. We're just gonna check if k is to the left of mid, or if it's the right. What are you gonna do? If it's the right, as I mentioned, guys, you have to change the current value to its inverse. So if current is equal to 0, change it to 1, else current is equal to 0. This is the most important part. Now we have to change the pointers. Remember, if the k is to the left of the middle element, we're gonna change right to the middle. Correct? Right pointer to the middle. That's what I explained. And if it's not, if it's the right of the element, we're going to change the left is equal to mid plus 1. That's it. It's as simple as that. And let's try to run this code. Right here. Possible OC conversion double to end. And if you type gas also. There we go. I think we're done it. All the cases are good. Let's try to submit it. Yeah, we're good. The thing is, guys, we're using Xi and we are iterating the n times because it's gonna take n times to find the k in the binary search. Usually in binary search, it's gonna cut the number of elements in half, and it's gonna keep going until it finds the middle element. But in this case, we are sure that it's gonna find the middle element at the nth time. So we're just gonna we'll just loop this. I mean, we're gonna loop until it reaches I less than n. Yeah. I hope you guys understood this. And this is a very simpler alternative than to solve the recursion, and I thought some people would understand this much better than the recursion one. So yeah, here it is. Thank you guys. Have a nice day. See you next time.